Alright guys, we're going to take a look at our notes for lesson 1.9 today. This is about estimating square and cube roots, okay? In 1.8 we talked about perfect squares and perfect cubes so that we could use those here in lesson 1.9, okay? So everything we did in 1.8 came out to those perfect whole numbers. In 1.9 that's not the case, alright? The part that's difficult about this is you won't be using a calculator. Okay, so we're going to use our chart that we made. I'm going to flip over to that real quick so you can see it. All right, so we've made a perfect square and a perfect cube chart. Okay, and so if you take a look at this, on one side of our paper we have perfect squares. So 1 squared is 1, 2 squared is 4, so on and so forth, all the way through 20 squared, which is 400. And then on the back side of our paper we have the perfect cubes. Okay, so 1 to the third is 1, 2 to the third is 8, so on and so forth, all the way up through 20 to the third power, which is 8,000. Okay, so we're going to be using this chart to help us approximate square roots in 1.9. Okay, so again, no calculator on this portion of our notes. Okay. All right, so we're going to get to it. It says you have a number that is not a perfect square or a perfect cube, and you can use perfect squares and perfect cubes to estimate the square root or the cube roots of that number. We don't want to leave numbers as decimals. Okay? So our steps to estimating square roots. There are 3 of them. The first thing you want to do is identify the perfect square or possibly cube that is closest to the number. Step number 2, we want to take the positive square root or positive cube root of each number. And number 3, we will evaluate either the square root or the cube root of each perfect square. Okay? We use 3 different symbols here. I use 2 of them all the time, but if you take a look at our book in lesson 1.9, they use a little symbol that's called in conclusion to. So I'm going to go ahead and show that to you as well. Okay? So we use the less than symbol. You guys are very familiar with that. You've used it before numerous times. This is the symbol that I said that the book uses. If you go in there and take a look at our notes, it's in conclusion to. It's basically like a little arrow. And then we have our last symbol that we use a lot, and we've talked about already this year, is the approximately equal to symbol. Okay? So, here we go. The first one. We want to estimate the square root of 51. You want to pay attention to the fact that it is a square root. Okay? So with that, we want to make sure when we flip over to our chart that we are using the perfect squares. Okay? So anything with the power of 2. And what we're looking for is to see if our number 51 falls between these 2 numbers. So we ask ourselves, is 51 between 1 and 4, 4 and 9, 9 and 16, 16 and 25, 36 and 49, 49 and 64. And we would finally say, yes, it is, okay? 51 is between 49 and 64. So let's flip back over to our paper here. And we said 49 is going to go on the left side. All right? Our number that we're comparing will always go in the middle. And then the other number that we found was 64. Okay? So that's step number 1. Step number 2 is we're going to go ahead and we're going to take the square root. Okay? So we're going to take these now and we're going to put square roots over the top of them. And we're actually going to answer them. So the square root of 49, if you're not sure what it is, again, you don't have a calculator, but you do have that chart, right? So the square root of 49, over here, the number is 7, okay? So we come back, we put a 7 here, all right? Square root of 51, we can't do anything with because we know it's going to become a decimal, but we do know the square root of 64 is exactly 8, okay? Now, here's the part where people get tripped up on. Okay? We need to figure out, is this number closer to 7 or is it closer to 8? And if I just tried to guess at that, it would be just that. It would be a guess. But if we look back up here to our first step, okay, And we want to compare the number that they gave us, which is the square root of 51, to the other two numbers right next to it. If I look here, there is a difference between 49 and 51 of 2. And over here, the difference between 51 and 64 is a difference of 13. So I have a smaller gap over here on the left side. And so I know my number will be closer to 7 than it is to 8. Okay? So we would say the square root of 51 is approximately 7. Okay? All right, we're going to do some practice down here. Okay? So this time we're going to estimate the square root of 128. And again, we're going to need to use our chart. So let's flip over here. Let's take a look at our chart. Okay? And again, we're remembering the number is 128 underneath. So 128. This one's a little bit weird because it falls in the break on our page. So there's 100 here, and there's 121 here. So there is the chance that it could fall between 10 and 11. Ours, fortunately, does not do that. It falls between 121 and 144. Okay, so remember those numbers. 121 is going to go on the left. Our number that they give us goes in the middle, and the other number that we found from our chart was 144. We then go ahead and take the square root. So again, using that table or the chart that we need to, if you need to flip back to it and take a look at what's next to 121, the number is 11, and the number here is 12. Okay? So 11 is going to be on the left side, and 12 will be over here on the right side. These two numbers will always be right next to each other. Okay? There's never going to be a gap of more than 1. So if the number on the left is a 3, the number on the right has to be a 4. Or if the number on the left is a 25, the number on the right has to be a 26. Okay? All right, and then again, we use comparison. So is 128, there's a gap of 7, where here we have a gap of 16. So the smaller gap occurs over here on the left side. So our answer would be the square root of 128 is approximately 11. Okay? Over here we've got the square root of 31. Again, we go to that chart and we find that 25 would be on the left side. Square root of 31 is what they gave us. It goes in the middle. And square root of 36, again from our chart, goes on the right side. Okay, square root of 25 is 5. Can't do anything with the square root of 31 that they give us. Square root of 36 becomes 6. So we look at the gap here. 25 to 31 has a gap of 6. Over here we have a gap of 5. So this time our gap is smaller on the right-hand side. So we know that our answer is going to be approximately 6. Okay? Notice that I have a gap up here. One side has 6 and one side has 5. Okay? If you're dealing with a whole number there in the middle, like 31, you will never have an equal gap on the left side in comparison to the right side. Okay? One side will always be either smaller or larger. Okay? Number 3, we have a cube root this time of 320. So remember, because of this 3 right here, that's important. Okay? So that means when we go to our chart, I do not want to be looking at the perfect squares. We want to move to the back side of our paper, and we want to look at the perfect cubes. Okay? So again, I got to take a look at that number, which is a cube root of 320. So 320. Now we're getting close. Okay, here it is. So it's going to be between 216 and 343. Okay? I'm going to flip back. We're going to take 216. We're going to put that on the left side. Again, the number they give us goes in the middle. And the other number that we got from our chart was 343. But this time, instead of taking the square root, since we're dealing with our cubes with the power of 3, we're taking everything to the cube root. So the cube root of 216 is 6. And again, if you don't remember where you got that from, since you don't have a calculator, you need to be a little bit careful. But you can just go back to your chart. Okay, across from 216 is the number 6. Across from 343 is the number 7. Okay, so you use that chart to help you remember what those perfect squares and perfect cubes are. Okay, and our number in the middle just drops down. And again, just like we did in number 1 and 2, we want to identify the gap between the number they gave us and the numbers that we're using from our chart. So from 216 to 320, there's a gap of 104. Over here on this side, between 320 and 343, we only have a gap of 23. So the gap of 23 is much smaller, so we want to pick this number over here on the right side. So that means the cube root of 320 is approximately 7. All right? Okay, so now the next step, okay? Just add just a tiny bit here. It's still fairly simple for most of you guys. I know when we did these together in class, most of you found it fairly easy. Okay? When we plot these on a number line, again, I think most of you are going to find this fairly simple. We're doing the same thing that we did on the front side of our notes. So over here, we are going to bring down the square root of 83. And we're going to pick the two numbers that go on each side. So again, flip back to our chart. Square root of 83. Notice that I'm in the powers of 3. So I can't use the power of 3s. I have to go back up to perfect squares, okay? And our number again is 83. So 83 is going to fall between 81 and 100, all right? So we flip it back, and we've got 81 that goes on the left, 100 that goes on the right, and we take the square root. So square root of 81 is 9, square root of 100 is 10, our number goes in the middle. And again, we want to figure out, is it closer to 9 or is it going to be closer to 10? So we look at this gap. Between 81 and 83 is a gap of 2. Between 83 and 100 is a gap of 17. So the gap on the left side is much smaller. So we know our number has to be closer to 9 than 10. So all of that we just did is exactly what we did on page 1. The only difference is I'm now going to take those numbers and I'm going to put them over here on our number line. Okay? So the 9 that we get from here, we put that on the left side of our line. The number that's on the right side, which is 10, we put that over here on the right side of our line. I put a tick mark in the middle to stand for 9.5 or 9.5. And all you have to do to get this correct in 1.9 is you have to place the number on the correct side of the middle. Okay? So if our number is closer to number 9, we just need to go ahead and put our point somewhere over here on the left side between 9 and 9.5. Okay? And that's it. All right, moving on to number 2. Again, be careful because number 2 is a cube root. So notice that it has that power of 3. So when we go to our chart, we want to be in the powers of 3, known as the perfect cubes. Okay? We are looking for the cube root of 100. So if we got to come down a little bit more, okay, 100 would fall between 64 and 125. So let's flip back. 64 is going to fall over here to the left side. The cube root of 100 goes in the middle. And the other side becomes 125. Again, we're using a cube root this time. So the cube root of 64 would be 4. The cube root of 125 is 5. And our number continues to come down in the middle. We look at our gap. So the gap between 64 and 100 has a gap of 36. Where the gap on the right side between 100 and 125 only has a gap of 25. So the gap on the right side of our paper is smaller, so we choose the number on the right side. Okay, so we're going to get approximately 5. And again, the number on our left side comes over here to our graph, 4. The number on the right side is 5. We put a little tick mark in the middle. And to get this correct, again, all I have to do is be on the correct side of the middle. Okay? So because our number is closer to the number on the right, I need to be on the right side of our middle. And I put this cube root of 100. And that's it. Okay? Number 3. We've got the square root of 170. So again, we flip back to that chart, we find it, okay? And square root of 169 goes on the left, is less than the square root of 170, which is less than the square root of 196. Square root of 169 is 13. Bring down our middle number. Square root of 196 is 14. Okay? So 13 goes to the left, 14 goes to the right. Our middle is 13.5. We look and compare our gap. Left side only has a gap of 1. Right side has a gap of 26. So we're closer to 13. So we have to be on the left side of middle, and we put the square root of 70. And our last one, we have a cube root of 62. Again, so you would flip back to that chart. I'm not going to worry about that right now, but you would flip back to that chart. You would find that 62 is in between 27 and 64. We take the cube root of each of these numbers. So the cube root of 27 is 3. We bring down our number, and the cube root of 64 is 4. And then again, number on the left stays on the left side of our graph, number on the right. Find something in the middle, which is 3.5, and compare our gap. All right, our gap between 27 and 62 is a gap of, 35. And then we have a gap over here between 62 and 64 of 2. All right, so we're closer to the right side. So I know my number has to be on the right side of the middle. It's going to be somewhere over here, which is the cube root of 62. Okay? Again, notice that I did not pay a ton of attention of how close it should be to 4 or how close it should be to 3. All we need you to do is to be able to determine, is it on the right side of the middle or is it on the left side of the middle? Okay, so closer to 4 or closer to 3. That's all we need you to do. Okay? All right, we've got a couple challenge problems on the back. So let's go ahead and scroll on over to that. It says Jasmine is estimating the square root of 200. She gave this for her answer. It says the square root of 200 is approximately 100. Describe her mistake in words and then fix it. Okay, so this is one of the most common mistakes that I see in 1.9, or any time we're dealing with square roots or cube roots. People think the opposite of square rooting, or not the opposite, but how to square root something, is by using division. And then that is not the case, okay? So what she did was she took 200 and divided by 2. And so she just thinks the answer should be approximately 100. Okay, we know that that's not the case. What she should be doing is bringing this number down. She should go to her chart. She should be paying attention to if we're on the square roots or the cube roots. Okay, our number is on the square roots, so we want to be on this page, and we want to find where would 200 fall between. 200 falls between 196 and 225. Okay, so we're going to bring that back and we're going to write it on our paper. 196 goes to the left, and 225 goes to the right. Take the square root of each of those. Square root of 196 is 14. Square root of 225 is 15. And our number, the square root of 200, just comes down in the middle. We pay attention to the gap. Over here we have a gap of 4. And over on the far side we have a gap of 25. So the gap on the left side is smaller. So we know our answer would be closer to 14 than 15. Okay? So again, like I said, what Jasmine did was Jasmine divided by 2 instead of solving out the square root. Okay? All right, and like I said, very, very, very common mistake that people do all the time. Okay? Challenge problem number 2 says, without a calculator, we want to determine which is greater, the square root of 94 or 10. And then we need to explain our reasoning. So, one way of doing this is like we've been doing, square root of 94. Okay? And on the left side of the square root of 94, we would go to our chart. Okay? 94. So I gotta move around here. 94. Look, it's gonna be between 81 and 100. Okay? So let's flip back. 81 goes on the left. 100 will go on the right. We take the square roots of each one, which gives us 9 and 10. So 94 to 100 has a gap of 6, and over here we have a gap of 13. So we're going to be close to 10, but that's not what it's asking us. It says, without a calculator, determine which is greater. Okay, the square root of 94 or 10. So, my number falls between 9 and 10. Alright, so I know that the square root of 94 has to be less than 10 because it's on the right side. Another way that we could think of this is simply think of 10. What is the square root of a number that gives us 10? So, the opposite of that would be squaring it. So if I take 100 and I take the square root of it, and then now I just bring this down that also has a square root over the top of it. Because they both have square roots, I can just look at the number underneath. So the square root of 94 is going to be smaller than the square root of 100. Okay? So again, 10 is greater than the square root of 94. And I proved that to you in 2 different ways. Okay? All right, so that will wrap up our notes here for 1.9. All right?